Let's say you're an explorer, standing at the edge of this huge, uncharted digital world. You know there are servers and computers and all sorts of devices out there, but you don't have a map. To really understand any network, you first need to see what's on it. And that's exactly what we're going to break down today, how you go about creating that map.
So how do you actually do that? How do you chart the territory, find the landmarks, and see who's home in this vast digital space? It's basically a reconnaissance mission. And for any good mission, you need the right tool for the job.
And that tool, my friends, is Nmap. It's short for Network Mapper. And honestly, it's pretty much the gold standard for exploring networks and checking on their security. Think of it as the ultimate Swiss Army knife for anyone who needs to draw a detailed map of a network. It shows you exactly what devices are plugged in, what services they're offering up, and can even tell you what operating system they're probably running. Okay, so every mission, and every Nmap scan is definitely a mission, it has to start with a really clear objective. You can't just scan the internet. That's not how it works. You have to decide on the exact piece of the digital world you want to investigate. You've got to choose your target. Now, this target can be super specific, like one single IP address. That's like the unique street address for one device. Or you can go a little broader and scan a whole range of IPs, which is kind of like checking out an entire digital neighborhood. You can even just give it a domain name, like example.com, and Nmap is smart enough to figure out the actual address for you. Once we've got our target locked in, the real work begins. And honestly, the best way to think about this next part is that Nmap is literally going to walk up to the target's digital address and just start knocking on all the doors to see who answers. But wait, before it starts knocking on every single door, Nmap does a quick check. Is anyone even home? This first step is called host discovery. It sends out a little ping, technically a probe packet, just to see if the target is online and will respond. If it gets a reply back, it's game on. If not, well, there's no point in scanning a machine that's not even turned on. Okay, so assuming the target is live, Nmap starts its most common and, frankly, most efficient scan, the TCP's SYN scan. It's really just a simple three-step dance. First, Nmap sends a special kind of knock, called a SYN packet, to a specific door, or what we call a port. Second, the target machine sends back a very specific kind of reply. And third, based on what that reply is, Nmap figures out the status of that door. Now This is where the magic really happens. This is how Nmap turns a simple reply into critical intelligence. If the target sends back what's called a SYNAC packet, that's basically the digital version of someone opening the door and saying, "Yep, come on in, we're open for business." That port gets labeled open. If it sends back an RST or reset packet, it's like someone yelling, "Go away," through the door. The port is closed. But what if there's no reply at all? Just silence. That's filtered, and it's a huge clue that there's probably a firewall standing guard, blocking our knock from even being heard. So we've knocked on the doors, we know which ones are open, which are closed, and which ones are being guarded. Our basic map is starting to look pretty good. But now we go from just mapping to actually gathering intelligence. We want to know what's going on behind those open doors. This is the really cool part. By analyzing the unique way a service replies, Nmap can figure out what's running on those open ports. Is it a web server? An email server? Something else? It can even get specific enough to tell you the version of that software. And then, by looking at tiny little quirks and how the target talks on the network, Nmap can make a seriously educated guess about its operating system. It's amazing what you can learn from just a simple digital knock. The reconnaissance is done. The intelligence has been gathered. All that's left is to put together the mission briefing, the final report. Nmap doesn't just dump a wall of text on you. It takes all this data, every open port, every service it identified, the OS guess, and lays it all out for you in a clean, organized, easy-to-read format. It turns thousands of little data points into a coherent map of the target, giving you a complete picture of its digital footprint. And this brings us to the most important point of this entire explainer, so please listen up. With a powerful tool like this comes a huge amount of responsibility. Security pros use this to defend networks, but it can absolutely be used for malicious reasons. So let's be crystal clear, scanning a network that you do not have explicit permission to scan is illegal in many parts of the world. So the bottom line, the number one rule, and it is non-negotiable, is this. Nmap should only ever be used on systems that you personally own, or on networks where you've been given clear, written permission to run your tests. This is the absolute bedrock of ethical hacking and responsible network administration, period. So, in just a few steps, Nmap turns a complete unknown into a detailed chart. At its heart, it's all about asking simple questions and sorting the answers into one of three buckets: open, closed, or filtered. From that simple idea, this entire incredible map gets built. It's an unbelievably powerful tool for learning, for defense, and for understanding the systems we use every single day. Nmap gives you knowledge, it gives you power. The real question is, how will you choose to use it?